In this video we're going to talk about all the fun things you can do with vectors. Well, you can't go to the movies with vectors or go for a walk along the beach, but if you like comparing them and adding them and subtracting them and reversing them and multiplying them by things, then I guess that could be considered fun. So first of all, we're going to compare them. Just imagine you were in, say, Adamstown and you wanted to travel northeast to Blacktown, and you travelled for 75 kilometres northeast. That displacement is exactly the same as if you were on a different continent travelling from Carrolltown to Daytown. Still 75 kilometres, still in the same northeast direction. So here's north and east, and there's northeast. So these two vectors are the same, even though they're in different places. They are the same. What else can you do? Well, you can multiply them. Multiply them by a constant. An example of this would be if I were, say, walking, so I have a velocity vector in this direction, say 1 meter per second, and I was travelling to the left, and I was just walking through the courtyard outside. If I then saw someone spraying graffiti on a wall across the courtyard, which would never happen here, of course, I might suddenly increase my speed by 3 times. So I could say I'm going to multiply my vector by 3, and that will give me a vector which is, look at that, 3 times as long. So this was my vector W because I was walking, and this is 3 times the vector W, and that's just how I'd write it. And you can see here that the size or the magnitude of 3W is 3 times the magnitude of W. So multiplying it by a scalar, or by this constant out the front here, is changing the size but not the direction. Just say I was travelling, again, let's start with W. I was walking across the courtyard, and I saw someone that I really didn't want to speak to right at that moment, for whatever reason. Use your imagination. I would want to turn around, so I would want to go the other direction and, say, run or walk quickly. So what I'm doing is putting a negative in front of it to change its direction, and multiplying it by 2, so I'm going faster. And what that looks like is simply the vector going in the other direction twice as big. So there you go, there's minus 2 times the vector W. And again, the size of it is twice as big as the original W, and it's pointing in the opposite direction. We can also reverse vectors, as we've seen just before up here. So if you have the vector A, which is pointing to the right, let's call it A, and I want to say this is a velocity vector. I want to say that I now want to see what happens when I turn that vector around and point it the other direction. We just call that the negative of A. And if I want to write that just a little bit more explicitly, I can say that negative A equals -1 times the original vector A. And that's just saying I'm turning that vector around. And here's the fun part. See, we said we were going to do something fun up the top here. We are going to learn how to add and subtract vectors. Just say I was displaced. My displacement was 1 kilometre to the north. Let's call it A. And then I went 1 kilometre to the east and call that B. So I could add those two vectors together. And you know this is common sense. If I first travel north and then I go east, they add top to tail. And what that means is our resultant vector, or the sum of those two vectors, goes from the beginning of the first one all the way to the end of the second one. So I add the tip of one to the tail of the other, and then the resultant goes from the beginning to the end. And that makes sense. If you walked north for a kilometre and then east for a kilometre, your resultant vector, your total displacement, would be given by this value, this line here. But what if I want to subtract two vectors? What if I want to find my change in velocity? So I would have to say the final velocity minus the initial velocity. And remember that these are all vectors. Yeah, look at that. Even the change in velocity is a vector. So let's draw that in arrows. Just say our initial velocity was this way, to the right, VI. And our final velocity was going down the page, VF. So I want to find out VF minus VI. Well, you know, the crazy thing is that VF minus VI is the same as adding the negative of VI. Hey, so that's cool. What we can do is add two vectors, which we already know how to do, and we just need the negative of VI. So let's draw the negative of VI. It's just going the opposite direction. So all we need to do now is add the vectors VF and negative VI. And how do we do that? We add them top to tail. And our sum of those two goes from the beginning of the first to the second, end of the second. So we have our change in velocity given by that line there. And you might need to stop and think about what that means physically. If we were first going to the right and ended up going down the page, we're kind of turning a corner this way, right? So we're turning a corner. First we're going across and then we're going down, which means something is pulling us this way to make us turn. It's pulling us towards the direction given by this change in velocity vector. And we're going to get back to some of these calculations again in some of the stuff we do in class.